Today's objective is geometric proofs. We've been doing algebraic proofs, and it is dynamic duo day, just like the dynamic duo of equals and losing. So, PB&J, Miss Marrero and I today went out of my way to make it an awesome Tuesday. Can make things out of clay. All right, well anyways, let's do this warm-up. All right, first step is always what? Given. So you write this first part down, and then on the right, you always write, like we just said, given. Okay, so if you hadn't been here, and by the way, we don't have headphones in our ears. We should never have two. We shouldn't have one or one. We shouldn't have our head down. All that good stuff. Now, first step, if I got those parentheses, what should I do? Distribute. So, distribute that 3 times x, 3 times negative 5. So 3 times x is 3x. And then 3 times negative 5 is minus 15. What's the property that I just did? Distributive property. And you can abbreviate property. Okay. All right. Now I have 3x minus 15. What's the opposite of that loner minus 15? All right. So at minus 15, we do add 15 to both sides. 3x equals what? 42, and my reason that I just did was addition property. Yay. Now, last step to get rid of that 3. What do I do? What do you do? Do you? Divide by 3 and I get what? Is that what I'm looking for? Yeah. And yes, the last step was division property. So, last 2 days of class, please. No, both. Now, last 2 days we've been doing algebraic proofs. This is an algebraic proof. Today we're going to get into geometric proofs. So, let's pass this out so you can have your properties first of all. This little half sheet you're about to get, by the way, don't do that, please. No one's passing or failing. All right. Here, put it away. Put it away. So you should be looking at this sheet. The front of it looks like this, and this is what we've already done. Algebraic proofs. These are all the properties of equality. So obviously add, subtract, multiply, divide, symmetric, transitive, distributive, all that good stuff, okay? Now, on the back is the new stuff. Put this away. Geometric. Now, this is stuff we've already learned this year, like vertical angles, angle addition postulate, part plus part equals whole, segment addition postulate, part plus part equals whole. We know what a midpoint is, what a bisector does. We know what congruent means. We know what a right angle is, how to substitute. Complementary angles, supplementary angles. We should know all that stuff, but we're going to be using those in a proof today so we can solve for what's using what's given to get what we need to prove. Okay? So, we're going to be on the front side of the assignment, please. Let's see here. Now, geometric proofs. Some of them are one-steppers, which are like a little bit easier, and then you have the longer proofs on the back. So we'll start with the easier one. Is everyone with me? This is brand new stuff. Okay? We all looking at the right thing? Okay. On your notes, I guess I should pass those out, right? All right, let me pass these out. No, I did pass these out. Who doesn't have the notes? Okay. Okay. M is the midpoint of XY. So what does midpoint mean? Middle, okay. What does it mean about these two segments, from here to here and here to here? Those segments are what? Congruent. Now, if you look at your little half sheet, it says it on here, right? So, look at the half sheet on the left side, kind of second from the bottom, right? It says right here, AM is congruent to MB, right? So we know if we see a midpoint situation, we know those two segments are congruent. So let's write that down, yeah. So my two halves, the name of the first segment is XM. So XM. And we're not putting equals, we're putting congruent, because we're talking about shapes, not numbers, right? So XM is congruent to what? M to Y, the other half. That makes sense. I see a midpoint. If that's given, then I know those are congruent. And what's the reason? So your little sheet says what? Second from the bottom. So what do we write for midpoint? Second from the bottom here. On the left side. Definition of what? Definition of midpoint. Of midpoint. Example 2, it says BD does what? Bisects. So if you look on here, bisector is on the bottom left corner, right? So definition of a bisector. And that's what these little tick marks mean. That means they're what? Instead of saying the same, congruent, okay? Same size, same shape, but that means the word we use is congruent for shapes. So if BD bisects ABC, the two parts are angles, right? Angle ABD and angle DBC. So let's write that down. Angle, what's the top angle? ABD. What symbol do I put here? The congruent one, okay? I know they're the same, but when we're talking about shapes, we use congruent. To angle, what's the bottom angle? From D to B to C. Does everyone agree those three letters are going to give you the names of those separate angles? I want you to not get behind, please. Now, what's my reason? So remember, I was looking at my sheet on the bottom left. What does it say there? It's a definition of a bisector. Let's write that down. Definition. What? So these one-steppers you can get out of here, okay? Let's look at example 3. Now, what kind of angles are angle 1 and 2? Vertical angles. It says it right there on the given. Now, this time it has 2 steps, but the first step is always what? So all you got to do is take this and rewrite it for step 1, right? So angle 1 and angle 2 are vertical angles. That's given. Where is vertical angles on your little half sheet? Like top left, right? The very first one. And it says that the angles across from each other are congruent, okay? By the way, the answer to everything is not always congruent, but so far they've been, right? So that means angle 1 and 2 are going to be congruent. That's what vertical angles are. They're across and they're congruent. So let's write that down. Angle 1, congruent sign, angle 2.
Crisscross applesauce, vertical angles are the same.
Now, if they're across from each other, they're congruent. And we write what? What? So all it says is vertical angles. Usually we write definition of vertical angles. Put that away. That's really weird. Put that away. So definition of vertical angles. So again, they are across from each other. Cool. Right. Now, those are the easier ones. I'm not saying they're easy, but they're easier than when you flip it over. On the back, now we got some longer proofs, but we can do it. I'm going to show you how to do it. It'll be a little bit easier on the assignment. So we're doing the harder ones on the notes here. Cool? So, bless you. Now, do you see how there's no like steps along the way? There's no training wheels on this one? That's all right, though. Okay? First step is always given. So we know, let's write this first line right here. So angle leg and angle 10 are vertical angles. Why? Because they're given. Put that away. Put that headphone in. Okay. First step, always given. Write what you see. The thing you want to do next is think, what does that mean? So we kind of did this on the previous page, literally the last one we just did. If they're vertical, that means they're what? Congruent. Again, on your little half sheet, that's the very first one. If they're vertical, then they're congruent. Okay? So that's going to be our second step. You basically just ask what comes next. What does that mean? Okay, so vertical angles means angle leg, congruent, angle 10. Okay? That's the next step. And yes, that's, again, looking at your little half sheet, it just says vertical angles. I'd put definition of vertical angles, because everything on the right side should be the definition or something else. Definition of vertical angles. Vertical angles. Okay. Now we're trying to solve what? We're trying to prove that x is 4. We're trying to get to some numbers, okay? So let me tell you, this is one step a lot of people skip. You can't skip this step, okay? You have to transition from shapes into numbers. So I'm going to tell you what to do. This has to do with a shape. The way you turn it into numbers is by putting an m in front of it. M means measure. So the measure of angle leg, okay, this is so important and new. Is everyone looking up here? Okay, can I actually see your eyes? Thank you very much. When you go from congruent and you start talking about numbers, you have to use the equal sign and the M's. Okay? So I had a statement about congruency. Now I have the M's and an equal sign. Okay? The congruent sign turns into an equals if you put the M's in front. Okay, measure angle 10. I want you to see how different these two steps are. This has to do with shapes up here. This has to do with numbers down here. From shapes to numbers. That's how you do it. Okay? And what is that step when you go from shapes to numbers? That's the definition of congruent. That's what congruent means. If it's the same size, same shape, then the measurements are equal. Definition of congruent. And again, that's on your little half sheet on the top right. Definition of congruency, whatever. Congruent, congruency. All right, now, next step. I want to turn this into, again, numbers. Now, do we know what the measure of angle leg is? It's right there. And do we know the measure of angle 10? It's right there. All I need to do is replace. Now, what's the math word for replacing stuff? Substitution. So our next step is we are going to substitute. Cool? So, you with me? Measure of angle leg, I'm going to replace it with this. So 10x minus 10 equals, and then the measure of angle 10, 8x minus 2. That was substitution. Property. Do you see I'm just replacing with what I was already given? Cool? Now starting right there, if that was your warm-up today, could you solve this algebraically? So how is the geometric proof different? You're starting with shapes. It turns into numbers, and it turns into what we've been doing. Okay? That's all literally geometry is. It's taking real things, turning it into an algebra problem. Okay? So, next step. X is on both sides. What do? We're going to get rid of our smaller x, which is 8x. So it's positive. I'm going to subtract. What's 10x minus 8x? 2x. Bring down. Minus 10 equals negative 2. And on each side, I just did what? What did I just do on each side? Okay, well, this last step was subtraction property, right? But yeah, my next step to get rid of that minus 10 is going to be adding 10, okay? So again, loner's got to go. The opposite is to add 10 to both sides. So 2x equals, what's negative 2 plus 10? 8. And since I just added on both sides, my reasoning is going to be addition property. Addition. No, addition. Last step to get rid of that 2. Divide by 2. Divide by 2. X is equal to what? 4. Is that what I'm looking for? It is. Okay. So that is, again, division property. You're proving that it's true. So, right, we know they're true. And the math, or the thing we're learning is how do you get from point A to point B? And actually, you know all these steps. It's just you putting them in order with the right reasons. Okay? That was a good question. So you know if they're vertical, that means they're congruent. If they're congruent, then they're equal. If they're equal, then you plug it in, and then you solve each step. So it's like each step I trust y'all with, but it's just you got to be able to say, put them in order, you know? Okay. let's do example 5. If you need to take a picture of that, you can, real quick. Not yet. I'm waiting, you know. The whole YouTube world is waiting for you to take a picture of this picture. All right. They're not there yet? Wow. No silly band for you. All right. Now, example 5, we always start with what? The given, right? Let's wait. So let's write this down. Angle POG and angle GOT are a linear pair. Whoops. Try to write, not small, but try not to take too much vertical space. This one has a lot of steps to it. We're doing the tough ones together. The ones you're going to do will be a little bit, hopefully, easier. First reason is what? Given. Now, this is not the exact same as example 4 because it's not vertical, so they're not congruent. What's a linear pair? Two angles that are linear pair. It's in the name. Linear. They make a what? A line. Good job. So, linear pair make a line. How many degrees is a straight line?
180.
180? Very good. That means if they add up to 180, what does that mean? What's that called?
Supplementary.
They're called what? Supplementary. Good job. All right, so now check it out. If they're linear, we know angle POG and angle GOT are supplementary. How do I know that? How do I know linear pair means they're going to be supplementary? It's the definition of, what's your last step? Linear pair, okay? So basically you're saying, what does that mean? What does that mean? What does that mean? It's usually the definition of whatever you were just doing, okay? So we were just talking about a linear pair. I know they're supplementary because that's the definition of linear pair. Got to write fast, I know. Now, if they're supplementary, and if I'm on time to class, then I know that POG and GOT add up to how many degrees? 180, good job. So, I'm going to write that down. Since I'm talking about numbers, 180, what do I put in front of the angle sign? A little M. Remember, if you're talking about numbers, right, you got to put an M. So, the measure of angle POG plus the measure of angle GOT equals how many degrees? Wow, 180 degrees. Now, what do you think that's the definition of? You get it from the step you just did, right? Oh, that's the definition of supplementary. It's also on your little half sheet of paper. Definition of supplementary. Now, here's the dealio. If I got the M's here, do I know what the measure of angle POG is? Oh yeah. Do I know what the measure of angle GOT is? Oh yeah. So now I can do what? Replacing them or substitution. So let's do that. This should be 2x plus 5 and then 3x. All I'm doing is replacing from what they gave us at the top. I know what POG should be. I know what GOT should be. Replacing is substitution property. Substitution property. Now, next step. Does everyone see I got two x's on the same side? 2x and 3x can combine because they're on the same side. Same side, combine. Right? People with phones in their hands? After this. Now, 2x plus 3x is 5x. Bring down plus 5 equals 180. And we just said we combine like terms. Combo like terms. Now,
But the only way you can combine them is how?
you can only combine on the same side.
On the same side. The people
You can
are
only
still
combine on the same side.
on opposite sides.
Why would they do that?
Yeah, why would they do that?
That's crazy. Now, you should be able to solve this. What? Which one do I get rid of first? Don't say 5. Obviously 5. Which 5? The loner 5, right? So, how do I get rid of that plus 5? Get this down? The opposite of plus 5 is minus 5. So, minus 5, minus 5. Okay, 5x equals, what's 180 minus 5? 175. What was that reason of what I just did? Subtraction, right? I just subtracted 5. Subtraction property. And then, how do I get rid of that 5? Divide by 5. X equals 35. That's division property. Now, wait a minute. What am I trying to prove? This. So I'm not there yet, but I'm close. If you know X, you can plug it in to GOT. Okay? So, 2 more steps. Ready? I'm going to rewrite measure of angle GOT equals 3x. That was given at the beginning, right? Last step, all I need to do is substitute, right? Replace x with 35. So 3 times 35, substitution, and then 3 times 35 is 105, which is multiplication. Actually, that's just simplifying, TBH. What does TBH mean? Truly bomb howdy. All right. Now, did we get measure of GOT equals 105 degrees? Yes, sir. So, there's that. On your assignment, you're going to be doing a lot of the one-steppers from the front of the page, and then I'll give you a multi-stepper. So if you hadn't been here, put it back on the front. Okay?